So all I'm going to do at the top, I've got a picture there for you that has what you would need marked for angle, side, angle. And it's two angles and the included side. So included side means it's between the two angles that you're talking about. So actually, let me color on this a little bit. So like if I color on A, that's yellow, that corresponds to D, right? And I'm going to color on this one too. Angle C is congruent corresponding to angle F. So you guys see how on both triangles, on both angles, I drew on the bottom of that triangle. The included side is one of the sides of both of the angles there. So that's why side AC and DF, that's going to be your included side. It's between the two angles. So in that picture, what's marked? AC and DF, those guys are congruent. Angle A goes with angle D, I just kind of colored that. Angle C goes with angle F. And then it says CAB, so if I want to complete the congruent statement, we got to match it up. So I went CAB, so I'm going to come over here and go FDE. And if you have those three pieces of congruent triangle parts, that is enough information to prove two triangles are congruent to each other. To start out here, I don't have a proof. I just want to ask you a quick question if you understand what I mean by the included side. And sorry guys, there's like a random line here. Just I don't know what that copied out. That's not anything. So it says triangle RST, which side is included between angle R and angle S. Okay, so I'm just going to literally, this is not to scale or anything. I'm just sketching a tiny picture of a triangle. That doesn't really look like a triangle very much. Okay, RST. So if I tell you I'm looking at angle R and angle S, what would you tell me would be the included side? What side would be included between them? Yes. Okay, so do you guys see that side is in both of those angles? So RS would be the included side there. Okay, now I'm going to go backwards here. It says in triangle NOM, which I totally don't have, so I'm just going to sketch a picture. And just go NOM. It says NO, so that would be this segment right here, is included between which two angles? So which two angles would that side be in between? Which two angles would that side be in between? Yeah. Exactly, good. O and N, right? That's in between those two, it's in the middle. So I'd say angle N and angle O. Just to help you so you can see these in the proofs today, it has to be the two angles, the side in between, to be able to use angle, side, angle. Okay, now, absolutely nothing marked in my diagram. And in terms of the given information, they do not tell me anything about any parts. There, it doesn't say any sides congruent to each other, doesn't say any angles congruent to each other. The first three steps, what I want to see is these two angles are congruent or these two sides are congruent and why. So I'm not going to copy, I'm not going to see anywhere in my proof these two lines are parallel. That's not giving me any parts. What I want to know is what parts I can have from that. So let me hold off on 1 second. Before I start the problem, is there any information I could just make a conclusion about from the diagram? That's what I would have you mark first. So we're trying to prove these two triangles are congruent, and I'm just going to go ahead and copy that. That's always the last step. Whatever you're trying to prove should be your last step. So triangle ADC and triangle DAB there, and you do not have to do this, I'm just going to color one on my paper. So I'm going to prove that this yellow triangle is congruent to this white triangle. Okay, can I have anything in that picture at all just from the picture? Any sides or angles that you might mark up just from looking at that picture? I know a lot of you worked on yesterday, so any sides or angles that I could have just from that picture? Sweet. Okay. Anytime you have a side is in both triangles, right? That's in the yellow triangle and the white triangle, and it's technically a set of sides. You just say it's congruent to itself, AD congruent to itself, and that is just your reflexive property. So right now, I've already got, I can't even spell, the reflexive. Okay, so I've got a set of sides. Now, other than that, I don't have any vertical angles or anything like that here. So what I got to use is the given information, which is parallel lines. If they tell you you have parallel lines, you should get 2 congruent angles from parallel lines being your given information. Somewhere in that diagram, I have 2 parallel lines. That'll give me 2 congruent angles. Okay, now this can be very tricky, so I'm going to use my highlighter here to kind of emphasize this. So in the given information, it says AB is parallel to CD. Oh, that does not look very pastel, does it? Okay. Now, options. You can use a bunch of different lines in this diagram for a transversal. I could use BD, right? That runs into both parallel lines, but in terms of angles, that would only give me angles in this white triangle. If I used AC, same kind of an argument. That could only give me angles that are kind of in that yellow triangle. What you want to use as a transversal here is going to be AD. All right? Now, if you have parallel lines, they can form same side interior, alternate interior corresponding. You're not going to see same side interior in a proof, but you will see alternate interior or maybe corresponding. So between the parallel line and the transversal, there's an angle right here. Between the parallel line and the transversal right here, there's an angle. Those opposite sides of the transversal in between the 2 parallel lines are called alternate interior angles. I'm just going to label them 1 and 2 just so I don't have to use all 3 letters to label the angle. You can do that if you want. I just like to number them, save me a little time. But I'm going to say angle 1 has to be congruent to angle 2 because those guys are alternate interior angles. Okay, now that is the only set of angles that I can get in those 2 triangles because of those 2 lines being parallel. Now, because it also says AC, that's the left side here, and BD, that's the right side there, because those are parallel, I'm going to also use that same line as the transversal there. Because those 2 lines are parallel, let's see if I can get another set of angles. Here, parallel line and transversal, this angle. Here, parallel line and transversal, this angle. I do have another set of alternate interior angles, but it's specifically because I have that other set of sides parallel to each other. And I'll just label those 3 and 4, but that's going to be the same argument. So angle 3 has to be equal to angle 4. Also a set of alternate interior angles. Okay, now, once you're there, if you can do this from the picture, please do. Sometimes I like to just kind of separate it really quickly, and especially if I've garbaged it up with my drawing all over the place like I tend to do, just so I can see better what I have. So I have that triangle there, and this triangle, I'm not doing a good job recreating this, but just pretend. What you have in each one of these, you have an angle, a side. So angles are curved, sides are the little slash. So I have an angle, a side, and an angle. Same thing here, angle, side, angle. The side is in between. So that's going to be my defense. This is angle, side, angle. I can just write ASA to abbreviate that so I don't have to write the words out. 2 angles and the side included. You have to be able, when you do this, you have to be able to touch the triangle parts in order as you go around the triangle. So like if I touch, like if I go here, angle, I wouldn't go around this way, right? Because I have to go too far until I get to the next part. I wouldn't start with the side and go angle, then I'd have to go all the way around to get to the next. You have to touch them in order. So I could do like here, angle, side, angle, or I could go the other way, angle, side, angle. But that's the best way I can tell you to kind of figure out which one of the methods you're using. Is anybody having a question? So, the next one. I do have just a tiny bit of given information marked in the picture, but not much. And I want to prove in this one, triangle VXW is congruent to triangle XYZ. So I'm just going to write that as my last step. Triangle VXW. We want to prove that's congruent to triangle, bless you, XYZ. And I may as well at least get that point, because I know whatever the last step is, that's what I'm going to try to prove. Okay, so again, I'm going to prove the yellow triangle and the white triangle are congruent to each other. Now, I would always tell you, just look at the picture. Do I have any reflexive property or vertical angles here? You don't. There's no side that they have in common. There's no vertical angles formed here, no X shape that's got angles. So we got to rely on the given information. They did do a little marking in the diagram for us that XW, which I'm just going to kind of extend a little bit, and YZ, these are parallel. Now, just because they're parallel does not mean they're congruent, but in this particular question, right after that, it does say in the given information, XW and YZ are congruent. So it does say that right in the directions. So if they give you sides or angles, go ahead and put that in your proof. XW and YZ, just given to us in the directions. They did not mark that in the picture. If they don't mark it in the picture, please mark it in the picture because it will help you see as you go through here more easily maybe which one of the postulates you're using. Now also, this one's nice, they give us another set of triangle parts. They give us a set of angles here. So angle W congruent to angle Z. This is, again, that was just given, but make sure, come over to the diagram. I'm just going to put like a single curve on angle W, single curve on angle Z. Those two angles are going to be congruent. So the only other thing we have to work with that I haven't used yet is those parallel lines. Anytime you got parallel lines somewhere in that diagram, you got two angles that are congruent to each other. Okay, in terms of a transversal here, you do have, again, several lines that run into this. The only one that is going to be helpful is going to be to use this whole line here as a transversal. Okay, now I'm going to mark two angles and see if you can see why I'm saying this. I'm going to tell you this angle right here, which would be VXW, which, because I had to use three letters to say that, I'm going to call angle 1. And this angle, I'm going to call angle 2. Can anybody tell me how I know those two? They're congruent, I promise. How do I know that? Yeah, these are corresponding. I don't think we've had a problem. We've had alternate interior, but we haven't had corresponding. So in this question, if you guys like think of this little group of 4 angles right here, if I pick that up, slid it up the transversal, the angle 1 and angle 2 are in the same location. They're both kind of in that upper right. So I'm just going to say angle 1 congruent to angle 2. Here it's because they're corresponding. If you have parallel lines, that forces corresponding angles to be congruent to each other. Okay, and then I'm just going to redraw one of these real quick because they're going to be basically the same, just different letters. If you look at what I have here, I have an angle, and then I have a side, and then I have another angle. So that's going to be my justification for why those triangles are congruent, angle, side, angle there. Is anybody having a question? Okay. All right, and then second reasoning here today. This is called angle, angle, side. All right, so this one's a little bit different. You're going to have two angles that are corresponding and congruent. So like here, actually, let me start. I'm just going to mark what's in the picture here. So it says AC, that's going to match up with DF. Now, angle A and angle D in the other triangle both have a single curve. So angle A is going to go with angle D. I have a double curve here on angle B and a double curve on angle E. So those two guys are going to go with each other. And then it says ACB, and that's going to be congruent. This one's kind of flipped. If I call that first one ACB, how do I have to label the other triangle to make that congruent statement true? Say that one more time. You're close. What were you thinking? Has to be DFE. Okay, so A and D go together, right? And I called AC. C doesn't have any kind of a mark, so the side that doesn't have any mark here is going to be F. And then it goes to B, which has the double mark. Then it goes to E in this triangle. So it has to be DFE the way that's lettered. Okay, so two sides, the non-included angles. So or two angles the non-included side. I'm sorry. So that is not between those two angles, right? So it's like an angle, angle, side, angle, angle, side. All right, so that is the last method we're going to talk about today. All right. Now, this lovely picture here, we're going to prove triangle WYX is congruent to triangle AYZ. And you do not have to do this, but I'm just, in one of mine, I'm going to color it, one of these triangles yellow. We're just going to prove the yellow triangle and the white triangle are congruent to each other. Okay, before I even read the given information, do I have any reflexive property here? No, we don't have any sides in common. Do I have vertical angles here? For sure. Okay, got that kind of that bow tie shape. If you got an X, right? I'm not even reading the given information, but automatically I know just from looking at that picture, if you have a reflexive property, I don't have that here. Vertical angles I do have here, and I'm just going to call those two angles 1 and 2, just so I don't have to write all the letters out. But automatically I'm just going to start, that's a set of angles I can have right now. Angles 1 and 2 congruent. Those are vertical angles. No reflexive properties, so now I got to go and rely on whatever the given information has for us. So if I look at this, they do actually give us a set of angles. Angle W is congruent to angle A. Says that right in the directions. Not marked in the picture, mark it in the picture. So I'm going to do a double curve since I used a single curve for my vertical angles. So angle W congruent angle A. Just given to me right in the directions. Okay, now we haven't had one like this today. The other given information tells you y is the midpoint of xz. All right, so I'm just going to highlight xz all the way across there, xz. If you have information that's given to you about a midpoint, that is going to give you somewhere in that diagram two sides that are congruent to each other. All right, so if y is the midpoint of xz, what two sides do I know have to be congruent to each other? If y is the midpoint of xz, what two sides in that diagram have to be equal to each other? What do you think? Perfect. Right here, xy. I don't know why I put a double mark, but I did. Okay, xy is congruent to zy. What would I use as my justification there? Yeah, tells you it's a midpoint. I want to see that over here somewhere as one of your justifications. So I'm just say definition of midpoint, and I'll just abbreviate that. All right, again, I'm just going to redraw one of these real quick outside the picture so you can see it without all my highlighting and everything on there. So I have angle, and then I put a double mark on that for some reason. I don't know why. Now, what you have here, you have to touch them in order. I have an angle, and a side. You could go side, angle, but we're just going to write it in alphabetical order instead. So angle, side is going to be two angles, and the side that is not between them is going to be what I have there. Angle, side. All right, now my next example is kind of tricky. We're not doing a proof. I'm going to give you some information and say, okay, what else would we need if we wanted to use a specific way to show the triangles in the diagram were congruent? So I just have this A, B, C, D, E, F. What else besides what's marked would I need to prove those triangles congruent if I wanted to use specifically angle, side, angle? So I've got angle B and E, those are marked both right angles, so those are congruent. Angle C, angle F, those are congruent. What else would I need to know if I wanted to use angle, side, angle there? Perfect, I'm just going to mark it right here. I would need B, C, and E, F to be congruent, because that's the included side between those two angles. Okay. Now, same picture. If I wanted to use angle, side, what would I need? Perfect. Okay, so I'm going to say A, C, and D, F. Was anybody else thinking anything different for that angle, side? Yes, this actually has two possible answers. You're totally correct. This is angle, angle, side, right? It's not in between the two. If, sorry, I should have put the diagram on here twice so you guys could see it. But if I have these marked, right? If I would have had, I'm going to go 1, 2, 3, 1, 2, 3. This side, which on that original picture, that would be A, B, and D, E. That actually has two possible answers to that question, because this, if I had that set of sides, that would also be angle, angle, side. So when you have angle, angle, side, there's sometimes two different places that side can be, depends on the diagram that you have. Okay, now same question. Now this question is a little different. If the triangles are like what I just looked at, they're not connected. They don't touch each other in any way, so you can't have a reflexive, you can't have vertical angles, you can't have anything like that. These two triangles touch each other, so most of the time, not always, but most of the time you'll have something like vertical angles, reflexive property. Right away, I would just mark in this diagram, like I've got a set of vertical angles. Now, this question is very tricky because this, you'll see it in a second when we mark it up, I think, but this is twisted. Okay, so I have this set of angles. I could defend that by just saying I got vertical angles, right? If I want to prove these two triangles congruent and use angle, side, angle, I do have a set of angles and a set of sides. So I need a set of angles to answer this question. Which angles would have to be congruent if I wanted to use angle, side, angle? Yes. Okay, so L here, P down here. So that way it would go angle, side, angle, angle, side, angle. So it has to be angle L congruent to angle P. That is the only way I could do that. Now, same diagram, but if I want to use angle, angle, side, and I do the same picture, so I have a set of sides and a set of angles, so I need a different set of angles, which one would it be there? Exactly. Angle M here, angle Q here. Angle M congruent to angle Q. Now, if you're looking at that, angle, angle, side, angle, angle, side. So sometimes those can be a little tricky because they can be a little twisted up. Okay, I have one last one, and I'm just trying to put in here different things you might run into as given information. Okay, right away, I'm looking at this picture, and I'm looking at trying to prove triangle SRP and triangle QRP are congruent to each other. So SRP, I'm just going to write that. Whatever I'm trying to prove, that's always my last step. So I'm going to put that right away. The other thing I'm going to do right away is I'm going to look and I'm going to see, do I have any reflexive property or any vertical angles? Because if I have that, I always just kind of mark that up first. And the two triangles, I'm going to prove the yellow one and the white one are congruent. Right away, just reflexive property, right? That segment's in both of those triangles. So I'll just start out with that. I'll just say PR. In both triangles, it's really a set of sides. I know it's exactly the same side, but if it's congruent to itself, it's in both triangles. We're just using the reflexive property. So that's a set of sides right there. All right, now, part of the given information, and remember, these first three steps can come in any order. So if you decided to write angle S was congruent to angle Q because it was given, that's totally fine. These can come in any order. But it does say right here in the directions, it's also marked for you in the picture, that angle S is congruent to angle Q. So there's another set, either sides or angles, or what I want to see in those first three steps and why they're congruent. This would just be given. Okay, now I don't think we've had this at all today. So it says RP bisects angle SQR. If you have an angle being bisected, it's an angle bisector, what you are going to get from that is going to be two congruent angles somewhere in that diagram. Okay, let me highlight what they're talking about. So they said RP, that would just be that line right there, bisects angle SRQ. Maybe I should have used a different color. That is a super wide, obtuse angle at the bottom of this. So what that's telling me, this line where it runs into that vertex at R, that's going to split that angle into two equal angles. So on either side, this is my angle bisector. On either side, this angle and this angle are going to be congruent to each other. And again, I'm just going to use numbers to help this go a little bit faster. I'm going to call it angle 1, angle 2. And in terms of my justification, they told me I had an angle bisector, so that should be one of my justifications. So I'm just going to say definition angle bisector. I know if I have something that bisects an angle, bisect means cut in half, so I'm going to get 2 equal angles there. All right, now, can anybody tell what I would use as my reason why those 2 triangles are congruent there? Say what? Yes, good. Angle, angle, side. You have an angle, and then a side. On this one, angle, angle, side. So I'm going to do angle, angle, side here. Does anybody have a question?